video, we're going to explore a two-stress temperature and voltage accelerated test. So before analyzing this data, how would we configure our interface to be able to accommodate all this information? We got obviously two stresses, temperature and voltage. Our time to failure is in hours, but we've also got suspension like this one, and we got a number of units with the same time to failure, or the same time to suspension. So to be able to recreate this interface, we go to live stress folder, right click and add live stress data, and we check that our units are in hours, so we're happy with that, and we're working with the data type times to failure data. We need to activate the first option, which is my data contained unit that did not fail, or rise sensor data, and also the last option, which is my data set contains row that represents multiple units. And in fact we got number in state, we correspond to what we already got, state failure or suspended, state and time, which is our time to failure. So now we need to insert the two stresses, so we go on next, and we have temperature activated. We need to also activate the voltage, and we need to change the use level. We're happy with the first one, 300 Kelvin, and we need to change the second to 10 volt, and after that we click OK. So that would create an interface ready to accommodate the same data. So as we already got the data populated, we're using this interface. So we got two stresses, and we got a series of combination. In fact, some of the results refer to 358.12, some of the others 378.12, 378.16, and lastly 398.12. We can verify our setting, our use level, which obviously refers to both stresses, so 300 Kelvin and 10 volt, and if we need to make any changes, clearly we can make changes here. And we cannot use the model we used before, because in this case we need to accommodate two stresses. We could, in theory, even if we wanted, switch off one of them and use a single stress, so analyze all these data, say for only the temperature. But we want to analyze the effect of temperature and voltage on our data, because the results derive from this combination. So we select a model that contains two stresses. There are two models present in ALTA, temperature, humidity, and temperature non-thermal. So we choose the second one, and we can either choose variable, log normal, exponential, and then it's up to us. So we choose the TNT variable configuration, and we click OK. Okay, that generates the model with the parameters, and we can select this one to just make sure that the temperature is assigned to the thermal part of the model and the voltage is assigned to the non-thermal part of the model. So we're happy with that, and after that we can look at the results, graphical results, and we can see this is the curve of the reliability, the function of time. So this is the reliability at use level, so at 300 Kelvin and 10 volt. If we want to see the results, the partial results, here we got the extrapolation at use level of our probability of failure on whiteboard paper. Here we got the results for the combination of 358 Kelvin and 12 volts. Here we got the results for 378 and 12, 378.16, and the most stringent one, 398.12. And similar to what we've done with previous example, we can also interrogate the system more precisely. So we want to know, for example, the reliability after 40,000 hours, and we can obtain the results. We can apply confidence band if we want, and that's it, simple as that.